Hello, everybody. As you can hear, that I am a forecaster. Also, I'm teaching meteorology at the Faculty of Transport in Zagreb for pilots and flight controllers, and I am also the trainer for the young colleagues who comes from university here at this at our office. I will speak more or less about the current weather in Croatia and all over the Europe. I mean the weather from the morning, and just from those who are not so familiar with the position of the Croatia and from Zagreb. The Zagreb is the capital of Croatia, and for example, here in Zagreb, we have very cloudy and cold weather because the temperature is only 13 degrees and it is really below the average from this part of the year. But from the other side, in Split, for example, this is the webcam at the National Maritime Center in Split, and it is the nice sunny weather with 21 degrees. I will not ask you, as usual, where you come from, because more or less the people are from Europe. And but first, I will ask you one informal question. What is your favorite season? Please annotate. What is your favorite season? Put the mark or put the star or put the whatever you want. All of them. Nice. Okay. Okay. For example, for me, the spring is my favorite season. But now one more formal question. Please put the mark. What is your occupation? I mean, are you a forecaster, researcher, trainer, or? Okay, okay, yeah. More or less, you are forecasters, or we are the forecasters or researcher. Okay, the other also. Okay, why I show you that nice images of four seasons, because this is the one side of the seasons. And for example, we also have the other example. In spring and autumn, often we have extreme connected with extreme weather, the flooding, and during the summer we can have a serious drought. And from winter, for example, this is the example with severe weather connected with freezing rain. And I just want to mention that here somehow we have some kind of subjective opinion of weather. But here's then there is the satellite products, and here's the models when you can get the information of objective state of the weather. And for example, here, this is the Airmass RGB from this morning. And this Airmass RGB is very useful because of course, this is one of my favorite, but you can get quick information of synoptic situation all over the Europe. You can define area of cold or warm air masses. You can get the position of the fronts of the cyclones. You can somehow distinguish the situation with, for example, with PV anomalies or with the jet streams. And what can we see at this morning Airmass? You can see for example, very interesting cloudiness over the West Mediterranean. And another one is over the Turkey and eastern part of Europe with some also convective cloudiness. Also, some convective cloudiness is connected with system near the Morocco border. Then we have a cloudiness stretching from north to south, connected with the frontal system and probably with some upper level formation. And from the other side, we also have a frontal system over the Atlantic and the frontal zone approaching Ireland and the British Isles, and with the cold and the warm front. And a lot of information just for the quick look on that RGB. And please now, this is one task for you. Mark the position of PV anomaly at this. I will not ask you to mark warm and cold air masses, but we start with a little more complex question. Yes. More or less, you are right. Well, why this PV? I mean, maximum of PV anomaly is important because it is connected with the or cyclones or upper level lows, and it can somehow. Let's look at the model fields, and then you can check your answers. Okay, we have a few maximum of a PV anomaly around for example, I saw at the chat box that, okay, here some colleague is from Morocco, and you have here a maximum of PV anomaly, and it is connected with this reddish or brownish color. Here also, here you have one maximum of PV anomaly. One is here over Turkey. Also one is connected with the frontal system here, and one is here in the east. Well, let's look at the mean sea level pressure to the surface chart, and this is analysis from ECMWF. You can see that at that point of where we have PV maximum of PV anomaly, we can recognize the lows here, yeah, or trough. If we look at the upper level, for example, we have interesting information situation at 500 hectopascal. I have here the upper level low connected with this cloudiness also here over Turkey. I also have a trough over western, let's say western part of the Europe, and well, this is the situation which is, for example, over Croatia, we don't have any, let's say, we have not gradient field, something like that at 500 hectopascals, but from this cyclone was affecting the weather in the previous days, and Kristina will talk about that later. Another question for you. I would, sorry, I would like that please mark the position of the jet. Also, can you see it on just look at that satellite image? Nice. Okay, what we can see, the jet stream is on an Airmass RGB represent with the brownish or reddish color. And better say that the position of the jet is in the transition from blue to red color, for example. We can't finally, well, look at the model field. Yes, this is nice position of a tropical jet. Here you can see the position of the jet also here behind the cold front. And for example, here you can can see this cloud, and this is the jet fibers. Yeah. Well, now you can see how good tool can be this Airmass RGB for analysis and forecasting the weather. I mean, forecasting the weather, you can somehow recognize what the weather will be in the next hours, for example. Airmass is, of course, the very useful during day and night. But for example, during day, you can take a look at the near natural RGB, where you can very nice distinguish the clear sky. I mean, the sunny weather at the for example, Croatian coast, and from the part of France and Pyrenees, and further to the east. And for example, also you can see the low cloudiness in yellow color, yellowish color above Croatia. Also here connected with that frontal zone and with the cyclone, and this bluish color connected with the higher clouds. This is the situation over the Croatia this morning, and as I mentioned before, this yellowish color is the low clouds. This one is another layer of clouds, is a middle cloud, and over the Croatian coast you can have a nice sunny weather. What the weather will be tomorrow, for example? Yes, I just put here the 300, 500, 850 and surface layer. And as we can see, we have a trough over western part of Europe. Here we can we have at 500 upper level low, and for Croatia, for example, in the southwesterly flow, we will have a warm advection. The temperature will rise in the next days, but still we have this unstable weather. I mean, because of that upper level low and because of that cyclone at the surface. Still, also we have a gradient in the field of mean sea level pressure, and which is mean that in this part of Europe we will also have windy weather. And that will be all for me. And once again, I would like to remind you of subjective precipitation of weather and models and all other data help us to change something like that. But in other way, this is not too bad. I mean, it's nice to have a subjective precipitation of weather.
Hi, everybody. I'm Kristina, so I'm going to continue the presentation for today's weather briefing, but I will turn off my video so that the connection is better. So I chose May 12th for a really easy reason. It's because I was in shift that day, so I'm kind of familiar with the weather and it was easy to analyze it. So let's first take a look at the synoptic situation. We will look at the Airmass. Like Dunja said, you can really get a lot of information from there. So we can see the really cold air mass coming from the northeast, and then the warm air mass coming here from the Mediterranean and north of Africa. And since you had the time to prepare yourself with Dunja, I would be very pleased if you could put here where you can see jet stream. Okay, very good. Thank you. So we'll take a look what the model says. You can really easily see the orange, red, brownish color that shows you where the jet stream is. And then we see it in this color because the dry air from the stratosphere is coming lower and gives this color. So also what we can see here that really near Croatia is a front that separates the cold and the warm, the cold air and the warm air mass. If we now take a look at the geopotential height, it's really nicely seen the two cutoff lows here on the western part of Europe and then all the way on the east, while in the north we have a ridge. So we can see that a lot of moisture here. If we take a look at Croatia, we see that the moisture is coming here from the Mediterranean and then going up with the flow. And we take a look at what's happening in the lower parts of the atmosphere. As you can see, over Croatia, there was almost no difference in the pressure. The sea pressure, there's only like a little weak lows, but what is interesting is here the front that we could see also on the Airmass RGB. It's an occluded front, and also this line of let's say convergation or really unstable air. So what do models say about the afternoon? What we are really interested in is the afternoon convection. And we have ECMWF, DVD, and our local model, Aladdin model. And as is expected, Aladdin can much better see the small convection possibilities. So early in the afternoon, we can see that here at the coast, he's expecting some convection and interior of Dalmatia, but nothing here in the north. And if we go a little bit further into the day, in the afternoon, you can see that there is a sign of heavy precipitation in 3 hours. So we should definitely look at that. And if you compare it to the other two models, they don't have such a good visualization. So since we saw that we can expect a lot of convection in the eastern part of Croatia, we will mostly look at this part. And why I chose exactly this place is because there is a little mountainous part, hilly part, not mountains, hills, and it's really prone to convection. And also, I took a look at the different parts of eastern Croatia, and here kind of was the best situation for convection. I also compared what Aladdin gave and what ECMWF gave. So Aladdin kind of has more moisture than ECMWF and more cape. So I would say with this skinny kind of cape, especially in Aladdin, I would expect a lot of heavy rain. Also, if we take a look at the wind speed and direction from lower parts up to the upper parts of the atmosphere, we can see there isn't much of change in the speed. We can say it's about 5 meters per second, more maybe in Aladdin than in ECMWF. So for convection to start, we need a trigger, either a mountain, like I said, why we chose that place, or also what can help us is wind. So if you please be so kind, would you show me here in the wind field if you can see any convergation lines? Let's see what happened and how the situation developed. So this is convection RGB. You can see at 10:30 UTC, that's around noon. You can see already some convection is starting over Bosnia because there is like a yellowish kind of spot here. And there is also some convection here. I mean, there is convection in other spots as well, but we are mostly concentrated here on this area. So what happens an hour later? You can see really how strong this convection here is because it's really bright yellow. So there are small icy particles. And now can you here spot by looking at the clouds, the convergence line? Okay, so if you take a look at here, you can see how this cloud goes, and this one here. So there is a convergence line exactly here. Okay, so let's look at the animation. You see, it's not so greatly visible as it will be seen later, but you can see how it forms exactly here at the place where I showed you. Goes again. No, it stopped. Okay, so I cannot annotate at the same time. Let's take a look then at the radar. It will be much better. You can see now how it formed. It didn't look as bad on the convection RGB, but here you can see, especially if you look at the side here, where you can see DBZ, that at some point, especially here, we have plum purple color, which indicates hail. There was hail also in Bosnia as well, but we are now concentrated on this area especially. The thing is that this system went really slow, and a lot of rain fell, most of the rain in 2.5 hours. According to rainfall from our radar, it's around 52 millimeters. So what's the impact? First of all, I have to say, so this is the amount of rain per day. These are the dates up here, and here is the places. These are the places that are crucial for our story. This is from the day before. Already we had some stormy weather and some extra rain. Actually, it was raining also some days before. But here you can see our stations didn't get to measure the maximum because it's not such a tight grid to get all the data. And we can see now, so this is in Požega. Požega is just in front of the mountains. You can take a look here. So as you can see, there was hail, really small hail. Just waiting for it. Okay. And here you can see, here you go. So there is hail on the, it looks like it was snowing, and you can see like icy river flowing down this. And the other one is just behind the mountain. It's called Čačinci. This is their kindergarten, how it looked like before that day. So, and this is what happened on the 12th. Okay. So here's also some hail, different shapes and sizes. Okay, this is going towards there. So the guy who was filming it, he had to go back because he couldn't pass. Okay. And then this is the kindergarten. It's usual in Croatia to put kindergartens and play area for kids in like lower places, so it would be safe for kids not to run on the street. But as you can see, it's a really bad place when heavy rainfall comes. So that's about it.